Database management systems have a logical view and a physical view. The difference between a database and a database management system is a database is a set of tables. They're freely accessible. But database management system has forms, query, and reporting functions. Database management systems has internal controls in place. So a database management system is a more extended version or more sophisticated version of a database. Database management systems have a set of integrated programs. First is they simplify the accessing and managing the centralized database. Second, it makes the data independent of the application process approach. That means the data is not dependent on the application programs. For example, if the enterprise wants to change the add-on software on the sales events to capture sales events from Salesforce to customer relationship management software, it is still okay because the data, whatever data that's collected, is independent of those add-on software. Still, when the add-on software is changed and when data is collected, then the data, whatever that is collected, then comes to the database management system, and it will collect those data after filtering those data through the business rules and then hold those data as independent of those application approaches. Third is it can integrate files from different application approaches, because although this data that's been collected and then from different applications, sales and purchases, for example, suppliers, and then new files are created, database files are created for sales, and then purchases, new database files are created, and these files are then interconnected. They are being related to each other through common identifiers, through database management systems, software. These files still can be integrated, although the applications approaches are different for the supplier and for customers. Fourth is uses database management systems uses three-tier approaches: the presentation tier, application tier, and the database tier. So the presentation tier is the reporting tier. So it's independent of the application and the database. Application tier is where the data is collected from the external to the enterprise and then accepted using business logic through middleware, and that's the second tier. And the database tier is where the data is being held, and all these three are independent of each other. They are not dependent on each other. They can change independent without affecting other. And database management systems uses the software to integrate the tiers. So there are logical and physical views of data in database. The logical view is what the users wants to see from the data, how the data should be presented to the users, how the report should be prepared, how the dashboard of the data should be shown. For that purposes, a data reporting software is used to come up with a set of instructions to show the data outlays, the type of data, and so forth. It's a balance sheet, income statement, cash flow, and so forth, and what items should be shown there. And then you can inquire into data through software languages like simple query languages, and ask questions from the data and get sensible answers. The second aspect is the physical view of data. The physical view of data is behind the screen, how the data is being formatted and kept in the data files. It is the schema, because data is memory. So memory has to be kept in certain order. And it should have structures to build meaning. And the structures or the schema is the physical view of the database. There are 5 advantages of centralized database. The first one, it eliminates data redundancy. Once the data is entered, it's entered only once into the enterprise, goes into the database file, and it sits there. It's easy to maintain data. You can delete, modify data, and it's that data, single data, piece of data that's been deleted or modified. There's data integrity because it's correct, it's more correct and holistic. For this, data are independent. It can change database without affecting applications in the database, as we previously talked about. We can change from Oracle database to SQL Oracle database, and still the data are intact. Fifth is the privacy. There's control over data access and disclosure. You can use various data encryptions and various passwords. Data could be encrypted using codes for data rather than actual data. We use a code to nominate that data, and therefore actual data is not released, but the code is released instead. Drawbacks. There are 3 drawbacks of centralized database approach. First is, if the database management system fails, it affects a greater part of the enterprise, because the central database of relational database, and then it relies for data, it relies on this database management system, and then the processing also can be affected because it cannot accept data from the processing. Data is compromised, there's a larger downside risk. Therefore, the business rules or the enterprise rules in accepting, maintaining, and deleting data has to be very robust. And then the question comes up, because in a centralized database, you get data from sales, purchases, and from human resources. These data are held there. Then the question arises, who owns this data? Whether it's the sales department, purchasing department, or human resources department. A solution to these drawbacks is to have continuous data protection, have contingency plan, data warehousing, and then third is to appoint a database administrator to look after administrative and technical issues that arise. When it comes to database models, there are 4 common models. These 4 models are hierarchical, network, relational, and object-oriented. Hierarchical database model is now obsolete. It's found in legacy or old systems, good for simple data structures. The network system is also now obsolete and found in old or legacy systems. More contemporary is the relational database models. They can accommodate numbers and text as data. They're widely used. And the future is towards the object-oriented databases. They can have numbers, text, objects as data. And at the moment, they are sparsely used. If you look at the logical or the user view of database models, the hierarchical database has one parent record and one child record. For example, it would have one bank account, a customer, and one the customer would have one savings account. In the network databases, it follows the hierarchical, but then it can have more than one node. For example, the customer could have a savings account, then term deposit account, and a loan account, and so forth. So it has kind of a network, and it overcomes the problems of the hierarchy as a result. The relational database follows a more logical, organized, two-dimensional tables. It has rows, and then it has columns. Columns are to represent different fields, information fields, and then the rows are to represent different records. That can be in a sales order table. It could have different customers as records, and each customer is in a given row, and then the columns would be about the date of the sales order, the value of the sales order, whether the sales order was processed or not, and so forth. Object-oriented databases allow storing complex objects like video clips, audio clips, in addition to numbers and text, and can be performed on the objects or as attributes. So hierarchical database model is transaction data of customer. For example, transaction data of recording a customer, but can't handle jointly owned accounts because customer for a single customer, there's single account, for example, in a hierarchical system, parent and child type relationship. In a network database model, it could have customer level data to start with, then have customer accounts, and then it could, under each account, there could be various transactions showing in each account. Relational database is two-dimensional collection of data, and they have a relationship, these two dimensions, and the relation between, and then they in a given table they have a relationship, the columns and the rows, and then you could also have another table such as with rows and columns, and allows one table or one file to be connected, talk to the other table or other file through a common identifier. So sales order file and the sales sales executed file can have, for example, customer name as a common field, and as a result, the two files can be related to each other or talk to each other through that common identifier. So if a customer, for example, bought a laptop supplied by a supplier, and then customer also bought a chair, and supplier also supplies mobile phones and desktop computers. Here the unique identifier common to the supplier data table and customer data table is the product. Could be the laptop. So through that product, we can the supplier database, customer database, or purchases database, and the sales database. We can connect these two databases. We can establish a relationship between these two databases using product as a common identifier, but the product should appear as a field in the supplier and also for the customer. Three elements in a relational database model is that there's more than one table in a relational database model. It could be one database data file for master data file for customers, another master data file for inventory. Then the reporting is done using across tables. When a reporting is to be done, it will use data from the customer file, it will use data from the inventory file, and then it can make a report using these two different database files. Can also query into data across tables, that is for the customers and the inventory, asking questions such as the sales quantity, sales quantity of customer, or the gross margin of customer, and so forth. I can make queries using this data. So the reports and queries are conducted using unique identifier first. These fields are included to complete the report or query, and unique identifier could be, for example, the first name and the customer. In this illustration, there's a customer data and supplier data. In both instances, we find that the first name of the customer appears. And using these two data tables, we can prepare a report inquiring into these two data tables that John bought 10,000 worth of goods supplied by kindergarten and record, because now we are using the two databases to inquire about John's buying behavior. So there are 5 ways of coding data. Sequential is you give a sequential number, like for a student name, we can give a student number. The second is the block codes. That means for a supplier, we give a certain codes. Products, we give another code. Third is hierarchical. A good example is the phone numbers, starting with country and service providers and the mobile number specific to the number. Mnemonics, it could have a name, course unit name like counting information systems, but the mnemonic is SAT 506 or 304 and so forth. Significant coding is where the product item is given a certain number, like Toyota is 23, Corolla is 12. Then where it is located, warehouse is given another number, and parts are given a different number. The fourth type of database model, which is the contemporary but is evolving now, is called the object-oriented database. It can store data in objects rather than in tables, and objects can be placed in hierarchy if required. The lower objects can inherit attributes from the higher objects, so that the common attributes or the so there's common identifiers between the lower and the higher objects, and it allows complex data types to be stored. For example, in object-oriented database at a workplace, you could have employee details. In that object called employee, their staff number, name and address of that employee, and then employee has a relationship with the supervisor, and then there's an object called supervisor. Supervisor's name, phone number, and address is there, and then the staff member worked in a certain branch, and then there's branch name. The object is the branch, and there's branch name, office room, where the staff member works, and the office address is also there. So these are the objects. These 3 objects here are the staff, supervisor, and branch. In each object, there's data that contains. And when a database is designed in accounting information systems, there are three categories to consider. One is the resources. The resources relates to assets, whether they are tangible or intangible. Second are the events or the occurrences, whether they are sales, purchases, or human resources. The third are the agents or the participants, are they people, enterprises, and so forth. And when an accounting system is being designed, we look at the how this resource, event, and agents or the participant gets arranged. So we identify the resource, then the event, like purchase order, generating event, and then the agent. Agent could be the purchasing clerk who is involved in processing the purchase order. And all these three are considered in designing an accounting system, information system. So if you look at a relationship building in REA, if you take an example, clerk is the agent that raises the purchase order, which is an event. Purchase order, which is an event, is sent to a vendor who is an agent. Vendor who is an agent send inventory, which is a resource. So all these three aspects become important. And when we design the accounting system, we can come up with this relationship between the resource and the agent and so forth. And this relationship, the business of this relationship, or the maximum number of relationships that we can have, is called the cardinality, the minimum number of relationships that we can have for each relationship. Segment of the relationship is called participation. So there could be different types of relationship: one-to-one, one-to-many, many-to-many. So if you look at a relationship here in this visual, we got orders, which is an event. Then we have an agent, who is a customer, and customer is placing, agent is placing orders, an event. And then because of that, there's a resource that's been used, which is inventory, and this resource is used to create another event, which is sales. And in this agent, resource, event relationship, there are various processes that gets connected. And in these processes, when we detail out these processes itemize these processes, there are activities, a collection of activities that take place.